Hello, my name is Huynh, and my partner's name is Kristina Wang. And today we're going to talk about the modern application of silicon. A little bit background about silicon is that silicon was discovered by a Swedish chemist named Johns Jacob Berzelius in 1824. It gets its name from the Latin silex, which means flint or hard stone, and it has a shiny texture. After purified, it has a metallic looking grayish crystals. However, it is neither a metal or non-metal. It is a metalloid, which is an element that falls somewhere in between the two. And it is found in rocks, sand, clays, and soils. Silicon is special due to the application in electronic devices because it has a very special property. And one of the most important properties that is a semiconductor, meaning that it conducts electricity under some conditions and acts as an insulator under the others. These characteristics make it an ideal material for making transistors that amplify electrical signals. It is also an extremely abundant to the earth. Its abundance allows it to be extremely affordable and appealing. It is no wonder why silicon has become the basis of memory chips, computer processors, transistors, solar energy, and other electronics.
As was mentioned, silicon can act as either an insulator or a conductor under different conditions. In its purest form, silicon is an insulator because it doesn't contain free-moving electrons. However, pure silicon can be converted into a conductor by adding a small amount of metal impurities through a process called doping. And depending on what kind of metal is added to the silicon, the material is converted into either N-type or P-type silicon. Both of which are viable conductors because N-type silicon has an extra electron and P-type silicon has a missing electron. And this process allows us to control and fine-tune the conductance and resistance of a material. Then using doped silicon, we can make silicon transistors, which are semiconductor devices used to amplify or switch electronic signals and electrical power. And using this technology, we've been able to create silicon chips and microprocessors that allow precise control over the flow of electricity and allow us to have to use this technology in more advanced applications. So this forms the basis of the electronics and computer industry. And here on the slide is a brief timeline of events related to advancements in the computing power of silicon devices. So starting in the 1950s is when silicon transistorized products began to appear. And there was also the invention of the monolithic integrated circuit, which is basically a set of circuits that are all contained on one small piece of silicon. And then in the 1960s and 70s came more advanced technologies that allowed for memory storage and the ability to integrate CPU or computer function onto a single silicon chip in what is called a microprocessor.
So another impact of silicon would be reducing high concentration of greenhouse gases and extreme climate change due to its application in solar cells and solar panels. Solar energy has become the most environmental advantaged source of energy due to its semiconductivity characteristics. These panels have the ability to absorb sunlight, and convert it into electricity without harming the environment. When the semiconductor is exposed to light, it captivates the light's energy and transfer it to negatively charged particles. It provides a combination of high efficiency, low cost, and long-term usage. Their lifespan is expected to be around 25 years or more and still produce an enormous amount of energy, more than 80% of their original after that many years. And therefore, silicon has a great impact in our daily lives.
And that was all we had. Thank you for your attention, and we hope you enjoyed our presentation.